Hello there, and then welcome to a brand new lesson. I do hope you are doing well. Now, in this lesson, we are looking at rational and then irrational divide. In our previous lesson, we learned about the natural numbers, the whole numbers, and then the integers. Now, it is important to know that all these are part of a larger family we call the rational numbers. With that said, the entire real number system is split into two mutually exclusive sets. One which we call the rational, and then the other we call the irrational, which I would use the image here to explain. So as you can see in the image we have over here, this small circle you have here is what we call the natural numbers. Okay, so they are the smallest set. Okay, our smallest set is what we have, or where we have the natural numbers. Then after the natural numbers, we move to another level, which we have where we have the whole numbers. So the natural numbers are inside the whole numbers. Then inside the whole numbers, we have what? Or outside the whole numbers, excuse me, we have the integers. So what that simply means is all the whole numbers are inside the set of integers. Then in the set of integers where we have the whole numbers, we have another set where the integers are in it, and we call that the rational numbers, represented by Q. You see, so the two major divides are the rational and irrational numbers. So if you take our real number system, which I've represented with this circular, this red circle over here, the very big one, we have two major. That is this, which written here is Q prime, and then your Q. So if you're a number, if you are not inside Q, then you are inside what? Q prime. With that said, let's look at what a rational number is. So looking at what a rational number is, we see that a number is rational if it can be written as a fraction. So any number at all that you have and can be written as a fraction, we term it as a rational number. So if a number is then written as a fraction, then it should have what? A over B, where we would say our A is the numerator and then our B is the denominator. And our B should not be equal to 0. Your B should always not be equal to 0. So any number that can be written as a fraction can be called a rational number. Now, what are some behaviors of what? Rational numbers? You should note that when a rational number is turned to a decimal, then the decimal is either a terminating decimal or a repeating decimal. So rational decimals are terminating or repeating. When we say terminating and repeating, what do we mean? When we say something terminates, it means it stops. You see, when something terminates, it means it has what? To stop. So if we take the decimal, or we take this here, which is a fraction, we say the rational number, if it is written as A over B, then if a number is written as A over B, then it's a rational number. 1 over 4 over here, if we want to change it into decimal, it becomes 0.25. Now, this decimal here stops. The number of digits you have at the decimal places is finite. It doesn't continue to the end. It is finite. You see, hence we say it terminates. On the other hand, if you have 1 over 3, 1 over 3 over here is what? If written as a decimal, it is 0.33333, and it continues on and on and on. It doesn't end. You see, so this is one way you can write it, where you put this dot over here to indicate that it continues. Or you can write 3 and then put a bar on top. This decimal is repeating. You see, so for rational numbers, if we want to express them as decimals, they terminate or they are repeating. But on the other hand, there is this group of numbers we call irrational numbers, which we will be looking at in a bit. They have a different decimal behavior. So let's look at what irrational numbers are. So irrational numbers are numbers, or an irrational number is a number that cannot be written as a simple fraction. No matter what you do, it cannot be written. The emphasis here is cannot. You cannot write irrational numbers as simple fractions. You see, so just as we look at the decimal behavior of rational numbers, let's look at the decimal behavior of irrational numbers as well. So when irrational numbers are expressed as decimals, they have two main properties you have to take note of. First of all, they are non-terminating. Non-terminating here means they don't end. They never end. Okay, we'll look at some examples. The second one is they are non-repeating. So it has no periodic or predictable pattern. Okay, so most of the times, if you want examples of these irrational number, we have the square root of the non-perfect squares. The square root of 2 is an irrational number. Square root of 3 is an irrational number. Square root of even 10 as well is an irrational number. All these are non-perfect squares. And we say they are what? Irrationals. Some of these irrational numbers are constants that we use in our everyday calculations. For instance, if you take pi, now the value of pi is an approximation. So it's approximated to 3.14159, and it goes on and on and on. You can even write it to the 50th decimal places. It is fine. Most of the times when you are solving for circles, area, and then perimeter and all that, you are being told that pi is equal to 22 over 7. But we are saying pi is an irrational number. Take note, this value of pi you have over here is just an approximation. It is not the exact value. You see, it is just an approximation. The actual value of pi does not terminate and cannot be written as a what? A fraction. Then other examples of irrational numbers are Euler's number. It is written as E, and its value is 2.718, and it goes on and on and on. Now, with all that we have done today, or in this lesson, we can then conclude that if you take your real numbers, which are represented by capital R, it is made up of the union of the rational and the irrational numbers. As simple as that. So with this said, let's look at some examples or some questions and then see how best we can understand these concepts. So for this first question we have over here, it says we have to classify the following numbers as rational or irrational. Just classification. Now the first number is a negative 1.5. Negative 1.5. Is it a rational number? We said rational numbers are those that can be written as what? Simple fractions. Now this negative 5.5, 1.5, you can rewrite it as negative 3 over 2. You see, if you have to simplify 3 over 2, you get 1.5. And this is a rational number. So we put it under rational. So it is a rational number. Now what of root of 9? So root of 9 is actually 3. And 3 can be written as 3 over 1. This is a fraction, isn't it? Yes. So we can say it is also a rational number. What of the square root of 8? Now we said for the square root of non-perfect squares, they are all irrational. You see, and since 8 is not a perfect square, then we can say this square root of 8 here is not irrational and hence is an irrational number. Then we have 0.12. Take note of the bar we have over here. This bar simply means it is 12, 12, 12, 12, and the 12 just keeps repeating itself. But then we put the bar here as a short and a simple way to write it. So 0.12 with a bar on it. It can actually be written as 12 over 99. We would go through how to do these conversions in our subsequent videos. Now, since it is able to be written as a fraction, then we can say it is a rational number, right? It is a rational number. So this is how far this video is going to get. As usual, I'll leave some exercises for you to try your hands on. So here are just 4 questions you can try your hands on. The first one says you have to classify whether or not if 7 pi is a rational or irrational number. Then the next one, which number is rational? Root 25 or the square root of 20. Then is the square root of 1 over 9 rational or irrational? And then the last one is a true or false question, as you can see. This is how Beyond Numbers, where we learn maths the easy way. If this is your first time on this channel, you can always choose to subscribe. That is, if you so do wish, so that anytime I release a video, you'll be notified as well. This is how Beyond Numbers. See you in our next lesson, and then bye for now. Stay safe.